Hello everybody, Caveman Math here, and today we will be discussing and solving factorials. Let's try to evaluate this factorial expression. To understand factorial expressions, I will explain this as simply as possible. I will explain this to you in a caveman method. Let me tell you about big number. Imagine you live in a cave, collect rock. You start with 1 rock, then you find 2 rock, then finally 3 rock. What will happen when you put all rock together? 1 plus 2 plus 3. You have 6 rock. That's like 3 rock in caveman math. But wait, if you have 4 rock, then you get 24 rock. That's 4 rock. If you find 5 more rock, then you end up with 120 rock. That's 5 rock. So if you have 4 rock, you get 24 rock. That's 4 factorial. If you find 5 more rock, you have 120 rock, which is 5 factorial. So even when you have no rock, you still have 1 rock. That is sacred rock. That is what factorial is. So let's just get into solving this, and it will clear up very soon. So 14, it's technically not only 14. 14, oh, where is my pen? 14 is 14 times 13 times 12 times 11. All of this is in 14 factorial stomach, and go so on and so forth until 1. But we're not going to go until 1 because we don't need to go until 1. We need to go until all of this. So now we have all of this: 14, 13, 12, 11. But now we have 3 factorial and 11 factorial. Now what happens when you have these numbers? Essentially, because this is still 11 factorial, because we didn't go on with that, so we can cancel this 11 factorial out, because technically there's more, but we didn't. We stopped at 11, so that's why this is 11 factorial. And because we stop here, we can cancel out the 11 with the 11, because both of them are factorials. But now we have a 3 left over. And what do we do with this 3, you say? Okay, let's dissect the 3. So we have 14, 13, 12 raw. Now you have 3. But 3 can be divided into 2 and 1. So you have 3, 2, and 1. And because you have 3, 2, and 1, we have 6. Because if you multiply 3 by 2, you have 6. So now you can multiply 14, 13, and 12 to get 2,184 over 6, which is crazy number. And if I bring up my calculator and just divide this, so 2,184 divided by 6, 364. 364 is our answer. And now let's go to the next one. We have 3 factorial and we have 7 factorial. Now what do you do when you have this type of odd situation? Well, first I would just recommend by just picking the number that you can dissect the most. Most preferably the biggest one. So let's just do the 7 factorial. We have 4 factorial. I mean, you might as well, but here, let's get it. So you have 7 factorial: 7, 6, 5, 4. Let's do 4 factorial. Because we have 4 factorial, we can cancel out this 4 factorial with this 4 factorial. And what gives us is 7 times 6 times 5. Alright, let's do 7 times 6 times 5, because we don't need to do all that. Alright, because I don't know what 42 times 5 would be. I don't want to do it in my head. 42 times 5, 210. That's 210. So now you have 210 times 3 factorial. Now what is 3 factorial? We need to expand 3 factorial into 3, 2, and 1. 3 times 2 times 1. So now you have this thing. And now it's 6 times 210. Now what's 6 times 210? Jesus Christ, dude. It is... 6 times 210, which is 1260. Alright, so this equals 1260. Alright, now that we have that, okay, let's see what this thing is, because clearly this is a different thing that we are approaching here. Number 3 here, we see, okay, what am I going to look at? A of n. We need to solve for a of n. So if we look at this really closely, we can determine that there's a factorial here. And honestly, I would just rule it out like this. We have an n here, so if it's a of n equals 1, so it's n plus 1. I would say this is times n factorial, because that's the only thing we have here. It's a 1. The only thing we have to draw from this is a 1, because it's not like a solid number. It's in parentheses. So that's why from this whole thing we can draw 1. If this was negative, it would be negative n. So that, you know, but it's not. But now we have a factorial of n, and now we have this n. So now we can cancel these out, and that leaves us with a of n equals n plus 1. That's crazy, isn't it? That's basically what it is. That's the answer. And now, if I look at this thing, okay, I have a big boy factorial here. It looks scary, but it shouldn't be, because the same thing is going to go on here. So, because we're solving for a of n, we have to look at this in this way. You're going to do a of n equals to 2n plus 1, but now this is times 2n. And honestly, you could just get this 2n and cancel it. You can multiply this by 2n, so you could cancel. Let's multiply by 2n. Alright, if we multiply by 2n, you would get it like this. So a of n equals to, wait, so 2n factorial. So that would mean that all of this is going with that, and then you would get 2n plus 1. That's basically it. Alright, thank you for watching, guys. See you in the next one.